Good morning, all. Am I audible, man?
Good morning, sir.
Morning, sir.
We are discussing some problem, conservation of energy problem.
Yes, sir.
Yes, sir.
Say for a spring, there'll be two types. You have, see, suppose this is a block. And there is a spring attached here. This is the natural length of the spring. Okay, here what are the forces? N is balanced by
MG.
mg. Spring force is 0.
We know. Yes.
So what is the spring force?
0.
So here this is the equilibrium position now.
Yes, sir.
I can say that understood this what is the equilibrium position.
Yes,
So now suppose from this point is the origin, I'll call this position as A. From this position, suppose the block is pulled. Now normal reaction is balanced by what?
MG.
Mg. Suppose is the extension, definitely there will be a spring force, no?
Yes, sir.
Agreed?
Agreed, sir.
Now the block is momentarily at rest now.
Yes, sir.
Momentarily at rest means just like
At
a
that moment,
particle thrown vertically up will be
momentarily at rest at the highest.
okay, clear. So here you can see, therefore, in this position of the block, but acceleration,
Vertical. Yes, sir.
understood this? I'm just trying to explain what is equilibrium position. So this is called extreme position. What is this?
Extreme position.
Understood this?
Sir, one doubt, sir. Sir,
Take.
other than this maximum position, we are just extending means at that position, block will be momentarily at rest, sir.
Pardon? I didn't understand what you're asking.
Means I am just extending, not till maximum extension or till extreme position. Uh, I am
One
just
second.
sir. So this extreme position means maximum extension now, sir.
Pardon?
So this now we told now, sir, extreme position of block. It
Mm,
means
mm, mm.
maximum extension now, sir. Maximum extension or simply extension, sir.
This magnet extension?
Yes, sir. I am just extending. I am not extending till maximum extension.
Then you'll have both velocity and acceleration. In between you are saying,
Yes, sir. Yes, sir.
okay. In between it has velocity and acceleration. See, for example, note down this. I'll just turn this. I'll explain.
Okay, sir. Okay, sir.
Shall I turn this?
1 minute, sir. Completed, sir.
Completed, sir.
Shall I turn this?
Yes,
Yes,
sir.
sir.
Okay. See here, between these two extensions, it's a common experience that if you just connect a block, this is equilibrium extension. Then you are pulling it, say by this amount. This is X max. Now, if you leave it, what will happen? Can you tell?
Acceleration.
Now the block will come this side.
Yes, sir.
The spring will pull, no? Again, the block will come to this position.
Okay.
Following or not?
Yes, sir.
Again, the block goes to the extreme position. Okay, so now you can see here there is an acceleration. Velocity is 0. Okay, now you can see that here velocity is 0. Here again, this is the acceleration, velocity is 0. When it crosses here, acceleration is 0 because spring is at again. This is not 0. Again, when it comes over here, there is an acceleration which is not 0 but velocity is 0. So it will be oscillating now.
Yes, sir.
Okay. A is called equilibrium position or mean position. Okay.
Yes, sir.
At this position, net force on block is 0. Understood this? See why I am explaining is in future you have oscillations chapter. There you should understand what is an oscillation. Okay. Points B and C. What are these called?
Yes, sir. Extreme position.
At these positions, what is 0?
Velocity 0.
Understood this?
Yes, sir.
Clear?
Clear, sir.
You remember that? Extreme position, maximum extension of the spring. Okay, there the velocity is 0.
Sir,
Hmm.
I didn't understand how do you say that acceleration is not equal to zero at its highest point and velocity is equal to zero, sir. If velocity exists, then acceleration will exist, sir.
Hopeless fellow. What you people are studying, man? Idiot. Leave these IIT batches. When you throw a stone upward at the highest point, what is the acceleration?
Zero, sir.
G.
Zero.
No,
G.
sir, acceleration
G,
is
sir,
not
G.
zero. G, sir,
At the
acceleration is
highest
G.
point, acceleration is zero.
No, sir, I got it.
Velocity 0.
At the highest point, G exists, na? Where G will go, man? Acceleration is zero or not?
Yeah. Acceleration is
Zero.
G, sir. No, sir, not G.
G.
At the highest point, acceleration is G. But
Yes,
it comes to momentarily at rest, na?
yes,
So at
sir,
the
yes.
highest point, what is happening?
Velocity is zero
Velocity
and
is zero.
acceleration is
Because of
zero.
acceleration, it is coming down. If
Yes,
velocity
sir.
is not zero, it will go further up, na? Here also, if velocity is not there, it goes. As it proceeds, the opposing force will be increasing. At some
Yes, sir.
stage, this velocity becomes zero. But opposing force will exist now.
Yes, sir, yes.
Whenever there is a motion against some force which always opposes motion, then what will happen? At some point, acceleration, velocity will become zero because of opposing force, it returns back. Clear?
Yes, sir.
Yes, sir.
So return this.
Yes,
One
sir.
minute, sir.
What man, what physics you people are doing? Huh? I'm scared actually. Where you people are going ahead? What you
No, sir, that was in vertical position. This is in at horizontal position, so I got confused.
What is the confusion when I was telling where is the confusion question here? There is a force always in this direction. The spring force, no?
Yes, sir.
As it moves on, spring force increases, no?
Yes, sir.
Increases, sir. Increases to backward direction. Means leftward
Shall I
direction.
turn this?
Yes, sir, completed.
Yes, sir.
Once again, see my syllabus completion, that's what it's very dangerous thing. This again that oscillation chapter throughout your life you need that, not today. See here, once again, this block is like this. This is L naught, spring is not extended.
Yes, sir.
Now you are disturbing this block. Now this is, you are pulling it. Okay.
Yes, sir.
Here velocity is zero.
Acceleration.
If you see that from here to here you are pulling, one force will act. What is that force? Spring force will act or not?
Back to leftward direction.
So there is a spring force in backward direction.
Yes, sir.
Understood this? So at this position, Okay.
Yes, sir.
So here now the block will be oscillating about this. Every time it comes,
Sir, one doubt, sir. Sir,
tell.
in this coordination, spring force Ax naught tends to pull back the block. Velocity equal to zero, but acceleration not equal to
Yes, sir.
zero.
How it is zero, sir?
Which one? This one, huh?
Yes,
Yes, sir.
sir. Acceleration is zero, you wrote, sir.
You are just you're pulling it and leaving. Okay, block disturbed from initial position and then left. When it is left here, this is the initial position.
Yes, sir. Initial position.
It will be momentarily at rest, no, sir.
Momental at rest, that is only momental velocity is zero, no?
So
At
That
that
acceleration will not be
instant.
zero, no, sir.
That's why acceleration is not zero. So.
yes, sir. Thank you, sir.
Okay, now it comes over here, again velocity becomes zero. Now spring force will act in this direction now.
Towards forward direction.
So acceleration is not zero. Again it comes here. Okay. Now the block is pulled like this. Again it comes like this. Here the block still has velocity. Okay, but acceleration is zero. Agreed? Clear?
Yes, yes, sir.
Yes, sir.
Again it goes like this. This is spring force. Agreed? Clear?
Yes, clear, sir.
It will be oscillating like this. Same thing I explained earlier.
Yes, sir.
Clear?
Clear, sir. Sir,
Right. So remember that two important things we should need from all this discussion is equilibrium position of block under action of what?
um, under some
Spring
spring force.
force. What will happen?
Sir, block is at equilibrium, so net force equilibrium. Acceleration equilibrium.
What is this called?
Um,
Equilibrium extension. Okay.
yes, sir.
What is zero?
Velocity equal to zero at extreme position.
Okay.
Yes, sir.
Okay.
Sir, bring this at maximum extension.
The minimum.
Extreme
Correct.
position.
Correct. So here you can see understood this?
Yes, sir.
Clear?
Clear, sir.
It is also called mean position. Clear?
Yes, sir.
So yesterday we were discussing that mean position. Huh?
Mm.
Shall I turn this?
One minute.
Yesterday we have done this. Do you agree with this?
Yes, sir. That possible zero.
Any doubt is that till here?
No doubt, sir.
Shall I turn this?
Yes, sir. Sir, one doubt, sir. So this
Tell.
delta K equal to zero at maximum extension means work done by all force equal to zero, right, sir? Sir, is it, sir?
Tell me.
Sir, if delta K equal to zero means work done by all forces is equal to zero, right, sir?
Work done by all forces equals change in kinetic energy. That is equal to zero, no?
Yes, sir. Yes, sir. That was my doubt, sir. Okay.
Shall I turn this?
Yes,
Yes,
sir.
sir.
So yesterday we were discussing on question, if you can recollect.
Yes,
Yes,
sir.
sir.
Postal related screens, sir.
So I'll just repeat what we are doing. There is a wall here. There is a rope connected like this. This goes on to the pulley. This is the block. Okay. Now suppose we need maximum extension. The spring is at maximum extension we got. So that means the block has come from where to where its initial position to this by x max. Okay. Do you agree with this or not? See here, remember
Yes, sir.
velocity is zero. but not acceleration is
Acceleration
not
0.
agreed. So now you can see that if you take any point of this is the spring force and this is the tension. So as rope is massless, what you have? Agreed. Now this is tension. Are you following or not? This is
Yes, sir.
mg. Agreed.
Yes, sir.
Actually here remember that kx max minus t is mass into zero acceleration. But mass of rope is how much?
0.
Acceleration is not zero. Remember, acceleration is not zero for the system. That is the reason why I am writing this directly. Follow this? Clear?
Yes, sir. Clear,
Now
sir.
for this I cannot write. I cannot write T is not equal to mg here. This
Yes,
is
sir.
remember wrong. Okay, there is an acceleration. So best thing what I will do is I will use work done by all forces equals change in kinetic energy. Okay, so what is that? A spring force is there, tension is there, mg is there. Is change in kinetic energy. Initially, the block is at rest. You're able to understand or not? So,
Yes,
what is the
sir.
work done by spring force? Minus half k. Final extension is how
Tension
much?
minus X max.
Initial extension.
0.
Work done by tension in the spring is zero. Net work
0.
done. Remember that?
Yes, sir.
mg x max into cos 0. Both are in the same direction. Okay, this gives you, yesterday we discussed this. Okay, and suppose we need equilibrium. At equilibrium, what we need? This tension is balanced by mg. Okay, and you can see that with equilibrium extension is this T equals kx naught. Therefore, T equals to mg, kx naught equals mg. X naught is what? Mg by k. This is what we call it as equilibrium extension. Now we can see that equilibrium extension is half of maximum extension. Understood this?
Yes, sir. Understood.
Clear?
Yes, sir.
Now,
Sir,
hmm,
if
tell.
spring is at its natural length, then what will be the tension, sir? It will be 0 now.
Tension is zero, no extension. Now, where from tension will come?
Yes, sir. Then that pull is also there, na, sir. Then that tension, how can it be 0, sir?
Which one?
That MG, sir, that block one. That block also has tension, na, sir. That is the same string,
No,
right, na,
no.
sir?
No, right. You are misguiding me and you are misguided. This is there now.
Sir,
Okay, at equilibrium, this is spring force. This is tension. So, how it will be zero, man?
sir, I am saying that it's natural length, sir. That spring's natural length.
When it is at natural length, you cannot hang the block only. How can you hang a block? Whenever you are applying a force, definitely spring should extend, no?
Yes, sir. Yes.
You want to hang a mass and spring should not extend, and that is not called a spring. You can keep an iron rod in that, then it won't be in place of spring, keep a iron rod. It also won't extend, no?
Yes, sir.
Okay, here our main focus is what is equilibrium extension, first thing. Second one is what is maximum extension. Shall I turn this?
Completely.
Completed, sir.
Right. Now suppose if you ask in the same question, find the velocity when the block is a spring, what you will do? Here again, what are the forces?
Spring force, tension,
Let the velocity be this. Initially the block is at rest now.
Yes, sir. What is the pressure?
This is x naught, initially no extension. Do you agree with this?
Yes, sir. Agree.
Now can you tell at equilibrium what you have?
At equilibrium, acceleration is zero.
And T equals mg now. This is what we have seen now.
What are
Yes, sir.
what equal to
So this
mg
is
by
nothing but
0.7d.
agreed.
Yes, sir.
Sir, agree.
Clear? Any doubt?
Yes, sir. No doubt, sir. Clear.
No doubt, sir.
If you want, you can write this also in terms of this. Clear?
Clear, sir.
Shall I turn this?
Yes, sir.
Yes, sir.
See, we can revisit the problems which you have done earlier. See, you have done that. There's a wedge like this. So this is the rod. This is alpha. Okay.
Yes, sir.
This is mass is 2m. The rod mass is m. Rod is constrained to move that means rod cannot move.
Down. Sorry, sideward, sideward.
Hmm. Follow till here.
Yes, sir. Hold on.
Now we can use this. See, suppose this goes in which direction? Remember all that Newton's laws?
Yes, sir.
This is the
Yes,
normal
sir.
reaction due to which it has two components. So that is the acceleration of this. I'll call it as A. Whereas the rod has an acceleration in which direction?
Downwards.
It has an acceleration A. Now how to frame constraint relations of this?
Sir.
Constraint relation.
But 2m.
Hopeless fellows, how to frame constraint relations? Along the normal, they should have the same components. This is alpha. This is alpha. 90 minus alpha, no? This is again alpha. So here A cos 90 minus alpha must be same as A cos alpha. That is constraint relation. Remember? Forgot, huh? Forgot.
No, sir.
Sorry, sir. Forgot, sir. Sorry, sir.
Do you agree with this?
Yes, sir. Agree.
Now, after this, what we will do is velocity after time t. Both start from rest now. So, one velocity will be at, the other one will be v is equal to u plus at, no? This is 0, no?
Yes, sir. U is 0. Other one is capital.
This is the velocity of the rod. This is velocity of wedge. Do you agree with this? Is it
Yes,
clear?
sir.
Agree, sir. Agree.
Yes.
After that, we simply apply law of conservation of energy. What is the law of what is the decrease in what decreases here? Which energy decreases?
So,
Rod comes down now. So what will happen?
Potential energy decreases.
potential energy decrease.
Decrease in potential energy of what? Now this is utilized as increase in kinetic energy of rod and wedge. See, wedge cannot move up or down, so its potential energy will not change. Do you agree with this?
Yes.
So
Yes, sir.
here mg height which it falls. half m. Okay, see this is VA. I'll call for convenience sake. Half m VA square plus half 2m VB square. Do you agree with this? So this is
Yes, sir.
mg. H is nothing but at square. Half at square, no? Remember this? Half
Yes,
m
sir.
at square plus half into 2m. What is
A
VB
cot
square?
alpha T.
A cot alpha t whole square. Till here, any doubt is there? Check up.
No, no. Yeah.
See, now you'll get A from this after cancellations are over. Check up.
Yes, sir. We can get, sir.
What is that you're getting A?
One.
What is? And
Yes,
A
sir.
nothing but understood this?
Yes, sir.
Not getting.
1 minute. Got.
Got the same answer?
Yes, sir.
Hello?
Sir.
Not getting.
Uh, uh,
Huh?
doing,
Will you turn this?
yes, sir.
1 minute, sir. 1 minute. Completed.
Finished this? See here, relaxed means no extension or compression. Okay.
Yes, sir.
Again the same story. At maximum extension, what happened?
Velocity equal to 0. Delta K equal to 0.
Okay, then you can use what?
Delta K equal to 0. After that, by voltage equal to
Here spring force, normal reaction on A,
yes, sir.
okay,
Mg,
mg on A,
uh,
then work done by tension, work done by mg on B, that's all, no?
yes, sir. That's it.
Equals change in kinetic energy of A and B. This is minus half K,
Yes.
final extension is this, initially no extension, these two will be zero. Why? Because opposite their perpendicular displacement, work done by tension is also zero. This is mg downwards, x max downward, change in kinetic energy. Block is at rest, no? Do you agree with this or not? Is it clear?
Yes, sir.
See, you have for tomorrow's exam only work for energy, only work calculation. This how to calculate work, those things only are having. Okay.
Yes, sir.
Complete this and we will meet in the next class. Okay.
Yes, sir.
Right. Any doubt is there?
No, sir.
No doubt, sir.
The mass of B is 2m, no sir. You wrote only mg there.
Where?
Mass of B, sir. Yes, sir, there. 4 mg.
Shall I turn this?
One.
Complete and go.
Yes, sir. Sir, completed, sir.
Right.
You can run, sir.
Sir,
Hmm.
how is it we are getting the final kinetic energy as 0, sir? That one.
Abrar, you have to use lot of brain, man. Some problem you're having. What I gave for magazine extension, read that. You're forgetting what the problem is under tension, I think. See? At
Yes, sir.
magazine extension of string, what happens? Just read that.
Velocity. Yes, sir. Yes.
Velocity is what?
0, sir. Yes.
Then